Alright, so I have the data right here. I have a scatter graph of the data right here, and we'll talk about the scatter graph in a second, and then I will have my results from the high-low method. We got a variable cost of 5.67 per unit and a fixed cost of $123,333. So let's look at the scatter graph right here. This scatter graph is just a plot of all of the data. And you can see on the x-axis down here, I have my volume. And on the y-axis right here, I have total cost. And I basically just plotted the volume and the total cost, and I plotted all the numbers from January through December. So for example, for January, we had a volume of 30,000. So I go to the graph, a volume of 30,000, I mark it over here, and we have a cost of $450,000. So I go to $450,000 right here, and if you line these two up, you get to this point right here, and I plotted that point. And then for February, we had a volume of 14,000. So that would be about right here. And then if we had a cost of February, $300,000 cost, total cost that is, so that would be right here. So if you take the total cost and match it up with the volume, then you get to this point right here. Well, I did that for all of this data for every single month, and I ended up with this neat little graph. So looking at this graph, we can see the relationship between volume and total cost. And you can see as volume increases, it appears that total cost also increases based on how these data points are arranged. Now let's look at what our high-low method told us. Let's look at our high point and our low point. Remember, our high point was in July right here, and that's when we had the volume of 40,000 and cost of $350,000. So if you got a $40,000 right here, $350,000 right here, you get this point right here. And then our low point was in May. We had volume of 10,000 and a cost of $180,000. So you go to the volume of 10 and a cost of 180, you get this point right here. So these are the 2 points we use to determine our variable and fixed cost. And if we draw a line between these two, so we take this point and draw a line, this line tells us the results of our high-low method, tells us our fixed and variable cost basically. When this line intercepts the y-axis right here, this is a fixed cost. And you can see that this is the same thing we got here, $123,333 for the high-low method. So this is $123,333 and this is our fixed cost, or at least what the high-low method told us our fixed cost was. Our variable cost, this is $5.67 right here. Our variable cost, that is the slope of this line basically. So this line right here has a slope of 5.67 and that is our variable cost, at least according to the high-low methods. So what is the slope of what does the slope of 5.67 mean exactly? Well, it means that on this line right here, if you increase volume by 1 unit, then the total cost will go up by $5.67. So if we move in this direction by 1, we'll have to move in this direction by 5.67. So that's what the slope's telling us. A 1 movement to the right would lead to a 5.67 upward movement. That is the slope of the line, and that's what we got from the high-low method. So if we got a fixed cost, which is where the line intercepts the y-axis, right here, we got the slope, which is an estimate of the variable cost. Okay, but if you look at this line, the line that was estimated by high-low method, you'll notice something. It doesn't really follow the data points. We basically estimated fixed and variable costs with just 2 data points, and it doesn't follow our other data point. Specifically, this point right here is much lower than what we would probably expect. I mean, for some reason, when our volume was 40,000, our cost only happened to be $350. And we probably would have expected this point to be up here somewhere. That's what we would have expected based on the other data. So maybe this point was just an outlier, and it's really not representative of other months of our data. So if one of the points we've used for the high-low method isn't really representative of the rest of the data, then the high-low method is going to give us bad results. And you can see it kind of did the same thing in this case. The line is below all the data points, and ideally we want the line to go straight through the data points to really estimate the relationship between volume and total cost perfectly or as good as possible. So to fix this, sometimes managerial accountants would just use a scatter graph like that, and they'll just move the line around to best fit to the data points. They won't use the high-low method. Instead, they'll just take this line right here and they'll say, let's just move this such that it best represents the data. So increase the slope a little bit, and I think this line better represents my data. And now from here, I can just figure out my fixed cost and my variable cost. I know my fixed cost is where the line intercepts the y-axis right here. So this looks like a fixed cost of about $140,000. And then my variable cost is just the slope of this line. And to figure out the slope of the line, we can use, remember back in your math class, rise over run. So if we can just take the rise over the run, so let's just take 2 points over the line, $20,000 right here. We have a total cost of about $300,000 right here, and then at 30,000 right here, we can have a total cost of about $400,000. So my rise would be from $300,000 to $400,000, which would be $100,000. And my run would be the distance this way, which was from 20,000 to 30,000, which would be 10,000. So my slope would be $10, or my variable cost would be $10 per unit. So using the scatter graph, I can better fit the line to the data, and you can see this in this method. I got a fixed cost of $140,000 and I got a variable cost of $10 per unit. So notice how these numbers are different than what we got from the high-low method. We got a fixed cost of $123,333 with the high-low method and a variable cost of $5.67. So you can see these are the estimations and the methods you can use, um, which will affect the estimation you get. All right, we've just used a scatter graph to fit this line to the data such that I minimize the distance between the actual data point. This will be the actual point, the actual data, and what's estimated on the line. So the line would estimate it right here. So I'm trying to minimize this distance, the total distance basically. So I'm trying to minimize this distance plus this actual data point to the line, plus this actual data point to the line, and two more of the same kinds of actual data points, and this data point to the line as well. So all of these data points, for each of the data point, I'm trying to minimize the total distance between all these data points and the line. So depending on where I draw the line, it'll increase or decrease the total distance between the actual data points and the line. When you add up all of these distances together, and you may even be saying that this is the way I was doing this just didn't seem very scientific at all. I was just kind of eyeballing it, and you're probably thinking to yourself, there's got to be a better way than the way he's doing it. And if that's what you're thinking, you're absolutely right. I was just eyeballing this. I was looking at the data and trying to put the line at the best place I possibly could. But you can actually use a computer to do this, and you can run something called a regression. So let's look at how we could do this on a computer. And if we run a regression model, that it'll basically draw the line for us, such that we minimize the data between the actual data points and the line. It'll make the best possible line. So let's look at that in the Excel. Alright, so I'm going to go to Excel now, and I have the data right here. I have my volume data and I have my total cost data. And the first thing I need to do is make sure that the Excel is set up to run regression. So I need to go to the file and then options menu down here. And then on the left hand column, go to add-ins, and then down here where it says manage add-ins, go to go. And then you'll get this little add-ins box, and make sure that the analysis tool pack is selected. So make sure it is selected and then hit OK. And once that's selected, you go to the data. And over here on the right, you'll see data analysis, and with that data analysis, select regression. It is already selected, hit OK, and then you just need to input your data. So the y-axis, that's what we're trying to explain. We're trying to explain the total cost, so that will be the total cost. So make sure the y-axis is total cost. Make sure the y-axis is selected. Okay, and then the x-axis, that's going to be our volume. So click this, select the volume, hit it again. Make sure it says labels, That'll give you a volume and total cost label, and then you can make sure this line fit plots. Make sure the line fit plots is checked, because this will actually draw the line for us, and so we can see how it looks. And then you just hit OK, and the output's going to look like this. You're gonna get your graph over here, and notice how on the graph we have total cost as a little blue dot. That's actually total cost. These are the actual numbers. And then the red right here, this is my regression line. So you can see the regression model made a line for us. And you can draw a line through these little red boxes, and there's my regression line. You can see that the program drew the line in the absolute best possible place to minimize the error between the actual numbers and the line. Now it also gives us a bunch of output. Let's look at what some of this output means. We're not going to go through all of this, but let's look at some of the important stuff. Let's start off with this coefficients down here. So right here in Excel, and you can see this intercept of $159,700.72, and that's right here. That's where the line intercepts the y-axis. So that is $159,701 approximately. So this is my fixed cost. I put FC next to it. This is basically the fixed cost, and that's the best estimate of the fixed cost that we have. And this number is different than what we got using the high-low method. It's also different than what we got when I drew the line just eyeballing it, because I can't do a good job as regression. I'm human. I can make mistakes. So this is the best estimate of fixed cost that we have calculated. Now in terms of the slope, you can see how the slope right here under volume, this coefficient right here, this is the slope of the line. So it's 9.069. So this line that the regression model drew has a slope of 9.069. And that's really telling us that for every dollar increase in the volume, the total cost goes up $9.69. And this is my variable cost. So that's my estimate of variable cost. So the regression gave us an estimate of the fixed cost and an estimate of variable cost. Those are given right here under the coefficients. Another interesting thing that the regression tells us is that it tells us how good volume is at explaining total cost. And you can see that with this R square measured right here. And it says that the R square is 0.544193046. And what that number tells us really is that the volume explains 54%. 54% of the variability in the total cost. So when we're trying to explain why total cost is changing or varying, you can see it varies on the graph. If you look at the little blue markings, they will vary up and down based on volume. Well, this is telling us that the volume explains 54% of the variation in total cost. And what that tells you is that there's other things that explain total cost as well. We're only explaining 54% of it. There's 46% of the total cost that's unexplained. So volume isn't the only thing that explains total cost. There are other things that also explain total cost. Maybe it's just not the sales volume, but it's the item being sold, or maybe it's the person buying the item. I don't know, but there's something else that's explaining this variation in total cost. In this model, we only looked at one variable, and that was volume, but you can actually do multiple regressions where you can look at multiple variables and see how they explain total cost, and that would give you a better understanding, even better estimation of your fixed and variable costs. But that's kind of beyond the scope of this class. And so that gives you an idea of what regression is. It's just a mathematical model that helps us best draw the line to minimize the distance between the actual values and the line. And if we can draw the best possible line, we'll get the best estimate of fixed and variable cost.